Hello kids, welcome. Let's discuss today's NEET question paper. Now for today's exam, if you see the chapters were halogen derivative of alkanes, second alcohol phenol ethers, aldehyde ketones carboxylic acid, amines, biomolecule, even you had got 11th standard chapters also such as hydrocarbon, general organic chemistry, nomenclature, isomerism, and there is one more chapter called as practical organic chemistry. I hope yes, we can start with our discussion. Fine. Let's see on the screen, child. We have got one question, and the question is IUPAC name of the compound is, and I think so 4 options are given. Basically, child, whenever you have got a structure, first of all, what you should know is, in this case, we have got a double bond and a halogen. Out of these two group, I think so which is a higher priority group? I think so it's a double bond. So, over here your numbering will start from this carbon atom as number 1, over here it will be 2, over here it will be 3. That means the third position is where you have got a chlorine. I think so out of 4 options, if you see, 3 chloro is your correct answer. Yes, out of 4. So, your correct answer for this MCQ is option C. I hope this is clear, child. Let's proceed with the next question what we have. So, on the screen the next question is, which of the following compounds can exhibit tautomerism? Now, child, what is tautomerism? Now, you have got one of the concept in 11th standard where you should know certain things like conditions for a molecule to show tautomerism. The first condition is presence of electron withdrawing group, and examples are like you have got carbonyl group, maybe of aldehyde or a ketone, you have got nitro group, you have got nitroso group, etc. So, this is the first condition, and the second and the most important condition is presence of alpha H, but which should be attached to sp3 carbon is must. Now, please wait. After looking these two conditions, child, let us try to visualize once again the question. Now, question is what? Out of this, which compound can exhibit tautomerism? Now, question is what? In the first example, you can see there is an aldehyde. So, first condition is followed. In a second example, you have got a ketone, yes, first condition is followed. Next example, you have got a ketone, you have got again ketone, means in all these examples, as the condition 1 is matching, so condition 1 cannot decide. Let us see the condition number 2. Now, in condition number 2, child, when you see, it is nothing but presence of alpha H. Now, in this case, I think so we do not have alpha H. That means this compound will not show tautomerism. In this example also, child, we have got a alpha carbon, we do not have alpha hydrogen. That means even in this case also tautomerism is not possible. In this case, child, when you see there is a carbonyl group, you have got an alpha carbon. Here you have got a tendency that there are 2 alpha hydrogen present in the molecule. That means this is one condition which can show tautomerism. Now, again in the last example, if you see, you have got a carbonyl group, but you do not have alpha hydrogen. That means in this also there is no alpha hydrogen. So, out of this 4 condition, the most appropriate answer for us in this MCQ is option C. I think so it is clear, bacha. Let us go ahead to the next question. Now, the next question is based on which of the following compound will show metamerism. Now, child, conceptually if you know, metamerism is shown by which compound? Now, there are conditions for a metamerism to be seen. First condition, metamerism is shown by polyvalent functional groups. Now, basically what do you mean by polyvalent functional group? Let us have a discussion on that. Now, there are certain functional groups, child, where on either side you have got an carbon atom. So, this is one ether. The second compound, if you want, you can have a ketone. The third compound, suppose if you want, you can have an ester also if you want to take it. Both the sides you will have carbon. Even the next example, you can have even a secondary amines which can show metamerism. Not only this child, how you have got oxygen, same way we can even have a sulfur also, which is a divalent. So, all these functional groups are such where on both the sides you can put a carbon atom. These type of compounds or functional groups are called as polyvalent. So, first condition, metamerism is shown only and only by polyvalent functional group, and I think so here it can show metamerism very easily. Yes, in this case also it can show metamerism easily. In this case also metamerism can be seen very easily. Is it clear? Now, one thing which you can simply remove it, I think so it's nothing but this, because in this example child you can't have metamerism. Now, out of 3 options left out, A, B and D, my question to you is what? All 3 will show metamerism as per condition number 1. What is condition number 2? Condition number 2, minimum number of carbon required, minimum number of carbon atom required to distribute on either side of functional group, either side of polyvalent functional group is 4. Minimum you should have 4 carbon atom to distribute on either side. Now, here if you check, I have got over here 1 carbon atom, I have got over here 2 carbon atoms. So, minimum is 3 in this case. How many carbon atoms you have got over here? 1, and over here it's again 2. That means in this case also if you check, again the number of carbon atom is not as per the requirement, but over here if you check, there is 1 carbon atom and there is 3, this make as 4. So, minimum number of carbon atom required to distribute on either side for metamerism is 4. So, as per the discussion, the correct answer has to be A. I hope this is clear, child. Let us proceed to the next question, which are what we have. Okay, which of the following molecule can act as a nucleophile and a electrophile? Now, basically there are certain thought process, child, what you should know, and that is what the atoms or a group which have got a lone pair. Can I tell that this is nothing but a one which has got an nucleophilic center, that is a nucleophile. Wherever you see in this case also you have got oxygen which contains a nucleophilic center, correct. But now what is the thought process? You should have a nucleophile also as well as electrophile, means your same compound should have both the centers, and the best example for that is nothing but I think so it's a factual data. Yes, it's a cyanide group, and whenever you have got a cyanide with you, if you see, does your carbon is less electronegative than nitrogen? So, nitrogen will act as a delta minus, your carbon will act as a delta plus. So, can I call the carbon atom is nothing but electron deficient center, and over here your nitrogen will act as a nucleophilic center. So, your correct answer in this case is nothing but option C. I hope this is clear, child. Is it clear? Fine. Let us proceed with the next question, child, what we have on the screen. Now, okay, the next question is, which of the following pair are resonance structure of each other? That means they are simply asking which are the two compounds which are resonance in nature, which are resonating structure in nature. Point number 1, child, do you remember one rule which I had told you? Position of an atom should remain same in all resonating structure. If the position of any atom is changed, it is not an resonance. Obviously, just see option number 2 if you want. Do you see over here, you have CH3 and you have got O. In this case, if you see, you have got one extra H over here, only one thing is missing over here, just I will put it over here as CH2. So, you can see over here, one of the H has been shifted. So, over here atom is changing its position, so it is not an resonance, it is not a resonance. That means second is not a resonating structure. So, wherever there is a second, cut it. I think so this is a second what you can see. So, this option is not possible. Even if you see here also you can see second, again this is also not option possible. Now, only the two options are left out where you can see your first and fourth. First and 4th are same. That means both of them are resonance, that's very clear. So, only one thing is which is left out to check is the third one to check. Now, is this a third structure? Yes, and I think so. Whenever a pi alternate to pi, the delocalization can take place like this, child. Your pi electron is shifted over here. So, this pi will shift over here. So, the structure is going to be same. That means, even this is a resonating structure, this is resonating, and even this is also resonating. So, all three are example of resonating structures. So, 1, 3 and 4 has to be the correct answer. So, your correct answer is D as per this MCQ. Is it clear, child? Okay. Let us move to the next question, child, what we have. Now, this is one of the very good question, child, what we have. Let us see what it is. I will just put it properly over here. Now, I want you to just check one thing, what they have given. Consider the following statements given to you, correct? And these are the two statements given to you. First one, this compound is more stable than methyl wala structure given to you, and same way other one. Let us see what I want to discuss. Now, here before we start, is this a positive charge alternate to pi bond? So, when this pi bond shifts over here, will I get a positive charge over here? Same way, when this electron pair will shift, so pi bond alternate to positive charge. So, electron shifts, you will get a positive charge over here. Is it term clear? Now, my question to you is this positive charge alternate to, sorry, not alternate, adjacent to the one who contains lone pair? That means this situation is nothing but of resonance, which is called as back bonding. I hope this is clear. And in this case, when you get a plus charge, can I have this case of an hyperconjugation? Now, out of these two, both of them are a stabilizing effect, but which one is a dominating? Yes, it is a back bonding. That means this is more stable and this is less stable. That means this statement is correct. Now, same way come over here. Now, here what you can see, this is a negative charge alternate to pi bond. So, what will happen? Lone pair will become pi bonds and pi bond will become lone pair. So, here you will get a negative charge, correct? In this case, child, what will happen? Your lone pair, the negative charge, lone pair will become pi bond will become lone pair. So, your negative charge will come over here. So, what is the difference in these two structures? If you see, this is that position where you get a negative charge, yes, and since negative charge is attached to an electron withdrawing group, so here it is again nothing but a resonance involved over here, and that is also nothing but which is a stabilizing effect in this anion case, whereas over here you are getting minus, but at some other position, not at this. So, this nitro group is not stabilizing this anion, okay, this nitro group is stabilizing. That means even this statement is also correct. So, both the statements are correct in this case, child. I think so option A is more appropriate. Is it term clear? Fine. Let us proceed with the next question, child, what we have. Now, they have given one very factual question based on NCERT, and it is based on the chapter Practical Organic Chemistry based on separation technique, and the topic is distillation. Under distillation, you have got one subtopic called as vacuum distillation. Now, what is vacuum distillation basically? Whenever, if certain liquids, when they are vaporized to their boiling point, and suppose if they decompose at their boiling point, then you can't carry out that method. So, what we have to do is we have to go for vacuum distillation, because in vacuum distillation what happens? Your substance will start getting boiled or vaporized much at lower temperature than its actual boiling point, and that is why the correct answer for this has to be a vacuum distillation. Yes, is it clear, child? Let us proceed to the next question, bacha, what we have. MCQ number 8. Now, they have given sodium extract gives blood red color when treated with FeCl3. The formation of blood red color confirms the presence of what? I think so, child, if you remember, this is one of the tests called as sodium fusion test, known as Lissagnes test. And in this Lissagnes test, I think so, if you remember, your organic compound, yes, is heated with sodium metal. After heating, it is going to form sodium fusion extract, that means solution. Now, basically what must be happening in this reaction? Let us see. Suppose if you have got, obviously we are taking sodium, so I have taken a sodium. If you have got sulfur and if you have got carbon and if you have got nitrogen, suppose in your sample, then they will combine to form sodium thiocyanate. I hope this is clear to you, child. Yes. So, this is what is formed when you have got sodium fusion test, and when this is treated with FeCl3, you get red colored solution, hence which confirms presence of nitrogen and which confirms a presence of sulfur, because this test will be possible or positive only and only if sulfur and nitrogen both are present, and hence that is why the correct answer is both nitrogen and sulfur. I hope this is clear, child. Let us take the next question, bacha. The ninth one. Which one of the following method is not used for estimation of nitro and azo compound? Basically, when you talk about nitro and azo, these are nitrogen containing compounds, and for nitrogen containing compounds we know one thing very clear, that Carrier's method cannot be used, because Carrier's method is used for halogen, it is even used for sulfur also in case of detection, correct, but not nitrogen. So, this is not the option, that is clear. Okay. And next important thing, acha, first two methods what you have got Dumas and Jadal's, both the methods are used for estimation of nitrogen, that means both can be answered, but when you are doing Jadal's there is one limitation, child, the compounds which contains nitro, azo or a ring, heterocyclic ring containing nitrogen compounds cannot be estimated by Jadal's method, that means even this cannot be used. Is it used? That means only one method which can be used is Dumas, correct, but the question asked to us is which cannot be. So, our correct answer has to be a Jadal's method, our correct answer has to be which cannot be used is a Carrier's method, and since both the methods are the right option for this MCQ, so your correct answer has to be both B and C. I hope this is clear. That means if you want to estimate nitro and azo, you can go by Dumas method. Is it clear, child? Let us proceed with the next question, bacha, what you have got on the screen. Now, what is they have asked? One of the very simple question, child. Order of Ka of the following acids is. Now, basically, child, if you remember one of the concept, acidic strength is directly proportional to Ka, which is called as dissociation constant of acid. Now, the question is, the one which will be most acidic in nature will be having a higher Ka value. One more important point, child, if you remember, acidic strength is directly proportional to percentage of S character. So, more the percentage of S character, more is the acidic strength. So, now here if you check the carbon atom which is triply bonded, the carbon atom which is doubly bonded, and the carbon atom which is, let us say, singly bonded. Out of so many carbon atom, child, which carbon atom will have got more acidic character? I think so, the answer is very straightforward. Your 1 has to be more acidic than 2, 2 has to be more acidic than 3. So, as per the discussion, what you can see on the screen is option A should be the correct answer. I hope this is clear, child, and it is all depending upon your percentage of S character. Is it clear? Sure. Let us proceed with the next question, bacha, what we have. Over here, the next question is based on arrange the following compound in decreasing order of stability. Now, basically, you have just find out the stability order of these alkenes. Now, when you start with stability, bacha, the first question what I need to ask you is, just give me 1 minute, I will make some adjustments. Yeah, my first question to you is, whenever you have a question based on stability, first you should check always a resonance. But here I think so in all these 3 examples there is no scope of resonance. So, the second topic is nothing but hyperconjugation, and we know that alkenes can show hyperconjugation. So, let us check that. And in hyperconjugation, what is the second condition, child? It is an alpha H. Let us check over here properly. Over here, if this is the alkene which I am selecting, the alpha position is, I think so, this carbon. Alpha is, I think so, this carbon atom, alpha I think so is this carbon atom, alpha I think so is this carbon atom. I think so. Is it clear? Now, how many alpha H's you are having in this particular compound? 2 plus 2 plus 2 plus 1. That means there are 7 alpha H in the compound number 1. Let us take compound number 2. Now, in compound number 2, if you check, this is alpha, neighboring position, this is also alpha, this is also alpha, and this is also an alpha. So, here the number of alpha H, if you check, we have got 3, 2, 2, that makes 7 and 1 8. So, here there is an 8 alpha H. Now, in the last example, if you check, this is that double bond. So, neighboring carbon atom is called as alpha, and it has got alpha H1 and it has got 2 alpha H. That means total number of alpha H is in this 3. Now, question is, what is alpha H? Why it is needed? Since we have done hyperconjugation, more the alpha H you have got, more is the hyperconjugating structure. If more the hyperconjugating structure, more is the stability. In terms, we can tell more alpha H, more is the stability. So, in this case, I think so, your second example has to be more stable than the first one. First has to be more stable than the third one. So, your correct answer in this example has to be the option B. I hope this is clear, child. Yes. Let us proceed with the next question. Okay, the next question is based on coal-based electrolytic synthesis. Now, let us have a discussion on coal-based reaction little bit. Now, see what is coal-based reaction. I have got a carboxylic acid in a form of a salt, let us say sodium salt or a potassium salt, correct. Achha, when you talk about electrolysis, you have to take the aqueous solution, so I will take over here water also, correct. Now, whenever you are carrying out electrolysis, yes, what happens? The first logic of the answer is, you have to take a 2 moles of the compound and both the alkyl groups will get coupled or double it. Now, what is this meaning of double it? Let us see. Over here, I have got an alkyl group. Now, one more alkyl group will come over here. Will I get nothing but symmetrical alkane as an compound formed? Is it clear? Now, what will happen? You will see that this carbon dioxide will come out as the second member. So, here 2 molecules of carbon dioxide is also given out. Now, wait, what is left out? Wait. Now, since you have used over here 2 molecules, even water also will be used too. And what will happen? Your sodium will go with 2 hydroxy group. Will I get nothing but 2 moles of NaOH formed, and along with that 2H will be left out. Can I call that hydrogen gas also will be given out. Now, this is a general reaction of a coal-based reaction. What additional information you should know? Alkane and carbon dioxide are obtained at anode. Your base and H2 gas are obtained at cathode. So, now as per a discussion, let us read one by one those questions. Over here, true statement you have to find out about the coal base. Hydrogen is liberated at anode. Hydrogen gas is liberated at anode. It is wrong. It is actually liberated at cathode. So, this statement is incorrect. Now, come to B. Carbon dioxide is liberated at cathode, which is also wrong. Carbon dioxide is actually liberated at anode. If you remember, we had discussed this. So, this answer is also incorrect. Now, pH of the reaction mixture decreases as it go on, which is also incorrect, because once the reaction takes place on and on, more and more amount of base will be generated, and as you have got more and more amount of base generated, your pH has to increase, not decrease. So, here even this statement also is not working that great. Yes. So, now the last one is left out is nothing but option D, and I think so saturated hydrocarbons are produced, and that is correct. It is a saturated hydrocarbon. Is it clear? So, your correct answer is D. I hope this is clear, bacha. Correct? Let us proceed with the next question, bacha. What we have? Okay, the next question is based on ozonolysis, one of the most important topic and very simple. In case of ozonolysis, child, if you remember, there was a shortcut given to you that whenever you have got a double bond, break double bond and put both the sides oxygen. Same way I can do over here also, put both the sides oxygen. Over here also I can do the same thing, both the sides oxygen. Here again I will tell both the sides oxygen. Now my question to you all, if you know little bit about your nomenclature, little bit, what is the question asked? The question asked is, propanol and pentane threone are the ozonolysis product. Now I think so I have given already the products. Now here see, I have got an aldehyde, but which is of 2 carbon only, which cannot be the case because you want answer as prop. So this is not possible. Even the same is true for this. There are only 2 carbon atom aldehyde, which is also not possible. Now over here I think so you have got 3 carbon atom, yes, aldehyde, and 5 carbon atom ketone, and that is also threone. So this has to be the correct answer. Let us see why this is wrong, because in this example, child, if you see, the upper part given is also ketone and lower part given is also ketone. So you have got both the compounds ketone, and it cannot be true because we have got one aldehyde and one ketone. That means even this answer is also incorrect. So your correct answer has to be A. I hope this is clear, child. Let us proceed to the next question. Acha, now this is one of the very good question, child. Benzene reacts with N-propyl chloride in presence of anhydrous AlCl3 to give predominantly which compound? Now, but if you remember, this reaction is what? Is nothing but of benzene, and benzene likes to undergo electrophilic substitution reaction, and I think so this reaction is Friedel-Crafts alkylation. Let us write the reaction properly. Now see, I have got the answer over here, a benzene unit, correct, and we are treating this with what? CH3, CH2, CH2 and Cl as the N-propyl chloride, and I think so the reagent what we have is anhydrous AlCl3. Now the concept is what? The first step of the reaction is the mechanism your electrophile has to generate. So what will happen over here? Your AlCl4 minus will get lost. So what is the product you have obtained? What is the situation you have got? The situation what you have got is, will I get nothing but CH3, CH2 and CH2 plus. Can I call this is a primary carbocation, and which is electrophile, of course, because your first step is generation of electrophile. But now we all know that your whenever carbocation is formed, you should give a chance to check carbocation rearrangement, and yes, here you can have a situation that your H can get migrate over here. That is only what we call it as hydride shift. So the arrangement would be of this type: CH3, CH and CH3. So will I get a plus charge over here? And I think so it's a secondary carbocation which is more stable, and the previous one was less stable. So why rearrangement generally takes place? Just to convert less stable state to more. And finally what will happen? Benzene likes to undergo electrophilic. Will it attack on benzene directly? Yes, and that is why the answer what you will be getting is not the one what we expect, but it is one which is rearranged product. Rearrangements you will get nothing but isopropyl benzene, and which is also known as cumene, one of the well known compound, but another name for that is isopropyl benzene. I hope this question is clear, child. Fine. So I think so this is what was discussed also in lecture. I hope this is clear. Let us discuss with the next question, child, on the screen. Oh here, yes. Which of the following reaction depict correct product? Now let us see one by one which reactions are there. I think so the first answer where you have got sodium and triether. Yes, in this reaction what is the logic? If you remember, over here your alkyl group gets coupled and here you get symmetrical alkane. So this is that isopropyl part which is going to get double. So I think so here we are getting that two double parts. That means this answer is correct. So Wurtz reaction. I think so the first answer is Wurtz reaction, child, you know that. Let us take the second one. I think so. What is they have given? Water and electrolysis. That means it's a coal-based electrolysis, and in coal-based electrolysis we have discussed whatever the alkyl group you have got, it gets a double. So I have got alkyl group of 2 carbon atoms. So your answer has to be of 4 carbon atom, correct? But here we don't have 4. That means this is incorrect. Now let's see the next answer. I think so. What is soda lime? I think so. Soda lime is used for decarboxylation. And what is decarboxylation? Here you will have what? Your carbon dioxide will get removed. And I think so. You will get nothing but alkane with 1 carbon atom less. So here there are total 3 carbon atom. So your product has to be of 2 carbon atom. But here I think so. This is given something incorrect, and that's why even this answer or this product is also wrong. That means out of 3 reactions, what you can say, A, B and C it should be, A, B and C it should be. The correct option you have got only is 1. The first answer only is giving you correct product, that is A. So only A should be your answer key. I hope this is clear, child. Let's take the next question. Now, okay, this is again one of the very simple question, child. Let's see properly what it is. Now, I will put it over here only. Now, the second reaction, what you can see, first I will talk on that. It is nothing but your HBO reaction. Is it clear? Now, in HBO reaction, what is the shortcut given to you, child? If you remember, the shortcut was add water molecule according to anti-Markovnikov rule. Do you recollect that, bacha? So, in this example, the answer can be like this. You have got CH3, CH and CH2, correct? Now, we need to add. So, according to anti-Markovnikov, you should have your OH part over here and H part over here. So, the product what you get is propane 1-all, which is correct. Now, the reaction which is the first one where you need to find out the A product is actually one reaction called as oxymercuration, demercuration, OMDM. If you remember, we have given a short form. Now, what is this answer? Here again you need to do what? It's nothing but addition of water molecule according to Markovnikov rule. And what is Markovnikov rule? Let's write that. I have got an alkene, which I think so you can see very clearly I have written. Yes, I have removed a pi bond. Now, I will add. Your negative part will come and attach to that carbon atom which contains less number. So, you will have OH over here and your H would come over here. I hope this is clear. Now, if you see, the name of the compound is propane 2-all. So, if you compare both the products A and B, what is the relationship between both A and B? Can I call they are position isomers, because one is 2-all, one is 1-all, functional groups is same. So, I think so the correct answer in this case has to be option A. I hope this is clear, bacha. Let's proceed to the next question. What we have? Okay. Which of the following reaction depict incorrect product? Now, child, the first reaction what you can see is, I think so this is given to you as a base. And you know that this is nothing but a terminal alkynes, and terminal alkynes are acidic in nature. So, when an acid and base reacts, it is going to give you a salt. This is one of the very common reaction, child. So, it is a correct reaction given to you, correct, and we have to find out what is incorrect. Let us come to the second. Now, child, there is an alkyne given to you, yes, and H2 given. So, it is an addition reaction, and when addition takes place, child, your triple bond will become double bond and double bond will become single. So, here you have got an addition product, even this is also correct. Now, reaction number C. Now, if you remember reaction number C, this condition is used as for hydration of alkynes. It is an hydration of alkynes. Child, if you remember, in case of hydration of alkyne, I have given you one important note point, that always whenever alkynes are hydrated by using HgSO4 and H2SO4, it always gives you ketone, it do not give you aldehyde. Only one exceptional aldehyde is obtained as acetaldehyde. That means, over here if I have got 3 carbon atom, child, it can never give you aldehyde, it actually has to give you ketone. That means this is only an incorrect product what is given. Again, when you see the last one, again you have got an alkyne, HBr has to be added. So, when HBr is added 2 moles, so first time you can add anywhere your H, anywhere your Br, and later on you have to apply Markovnikov. So, even this answer is also correct. Is it term clear? If you want, we can write the last reaction to just to check what happens over here. So, I have got over here alkyne. Yes, treat this with HBr. So, the first step is what? Since it is a symmetrical alkynes, addition can take place anywhere. So, I will make H to attack over here, Br to attack over here. So, your product obtained would be CH2, double bond CH and 1 Br. Now, again a second molecule, because they have given a second mole also. So, one more HBr. Now, your alkene is unsymmetrical. So, as per the concept, negative part goes to attack and that carbon atom which contains less number. So, H will come over here. So, your answer has to be CH3, CH with Br and a Br, and I think so this is only nothing but what we have got our product. That means, if you ask incorrect product, I think so your option C is the incorrect product, and which is nothing but a correct option key for our MCQ. I hope this is clear. Let's take the next question, bacha. Question number 18. Okay. What is question number 18, child? Consider the following compounds given to you. I think so there are 7 compounds given to you, and they have asked the number of compound species, whatever it is given, compound or species, which obey Huckel rule. Now, I think so you should know what is Huckel rule. Huckel rule is nothing but where you have got 4n plus 2 pi electron, where your value n is a whole number which can be either 1, 2, 3 and so on. So, suppose if n value is 0 or n value is 1 or your n value is, let us say, 2, the number of electron for delocalization over here would be 2 pi electrons. If you substitute your n value is 1 is equal to 6 pi electrons 1. That means this topic is used actually for to discussing the aromatic. Yes. So, let us see the first compound. There are 10 electrons, which is nothing but an Huckel number. So, even this is obeying Huckel rule. Over here also, bacha, we have got 6 electrons. If you see 6 pi electrons, here we have got 10 pi electrons. So, even this is also correct. Here it is a 4 pi electron system. Here it is not obeying Huckel rule. Here again it is see pi bond 2 electron and lone pair 2. That makes 4 pi electron system. Again this is also not true. Now, again if you see, child, question number 5. In that there are 2 electrons given over here and plus charge. So, it is a 2 pi electron system. Even this also obey Huckel rule. Over here, now see, this is one of the very important question, child. Here it is an 8 pi electron system. Now, whenever it is 8 pi, again it is not obeying Huckel rule, bacha. Again in this case, if you see, it is nothing but how many electrons are there in this? 14. So, it is a 14 pi electron. Again your 14 comes in Huckel rule only. If you want, you can check by putting one more carbon atom in this, one more n value. When your n is equal to 3, then your number of electron will be 14 pi electrons. That means, child, how many options you can see is correct? 1, 2, 3, and even this is also obeying it. So, there are total 4 compounds which obey Huckel rule, and then so this all 4 compounds are aromatic in nature. I hope this is clear. Let us see the next question then, child. What you have got on the screen? Okay, now bacha, we have done this type of question prior also. Let us check. Over here now see, this is a benzene ring and it has got 2 groups. One is chloro and one is nitro. Acha, benzene likes to undergo which reaction? Electrophilic substitution. Now, the question is which group will enter first? Now, before putting which group, now see, there are only 2 groups, one is chloro and one is nitro. That means once you have to carry out chlorination and another reaction you need to do nitration. Only the problem is what? The sequence, which reaction need to be done first and which need to be done second. Now the question is, what is the position difference between both the compounds? I think so it's a meta difference. That means first you should put which group? Obviously the first, which is meta directing. Now out of Cl and nitro, which is the meta directing? Answer is nitro. That means this reaction has to be performed like this. Take a benzene, treat this with concentrated nitric acid, along with that a sulfuric acid, correct? So the product obtained in this case will be nitrobenzene. I think so it's a very common reaction, child, nitration. And this compound on further treatment with chlorine. Now whenever if you want to carry out electrophilic substitution of chlorine, you have to use Fe, yes, dark condition, because if you use sunlight condition, child, it will undergo addition, whereas we have to carry out substitution, child. So here you will have what? Nitro is electron withdrawing group, and withdrawing group always gives meta product only. So incoming group will occupy meta position, and I think so we have got our answer also as meta. So out of this condition, first has to be done nitration. That means this is not possible, this is also not possible. Now out of these two reactions, child, the first step you can see is same, but second step is sunlight given over here, which is also not possible. That means your option A is also not there, only option C is a valid one. Is it clear? So your option key has to be C for this MCQ. Is it done? Let us proceed with the next question, child. Okay, one of the very good question, child. Arrange the following compound in decreasing order of reactivity in SN1. Now before we start anything about SN1, what is the important keyword for SN1? Yes, it's nothing but what? Formation of carbocation. And what is the second important point? Your reactivity order. Reactivity order towards SN1 is directly proportional to stability of C plus. So now we just need to find one thing, which carbocation is more stable, that will be more reactive. So do one thing, how carbocation is obtained? Remove the Cl out, and put a plus over here. So this is our primary carbocation. Okay, remove Cl from over here. Will I get a tertiary carbocation? Yes. Remove Cl over here. I will get over here a carbocation. Yes. Remove from here your Cl. Have a carbocation. Yes. Now out of these four carbocations, child, first of all the most important is B, because it's an aromatic in nature. I think so this is one structure which we have discussed in class. It will have 7 resonating structures and they will be all equivalent. That means your first stability wise has to be B, the most stable carbocation. Now after that we have got this one. Why? Because you have got a phenyl ring over here, means it's a benzene ring, and again it's a resonance. So even A has to be the next one in the sequence. Now out of primary and tertiary, which carbocation is more stable? This one is tertiary carbocation. So I think so your tertiary would be a better, and the last option would be option D. So your correct answer has to be B, A, C and D. So your most correct answer is, I think so, D. I hope this is clear, child. Can we go to the next question? Okay, which is the next question given to you? Which of the following compounds, which of the following condition favors SN2 mechanism? Now before we start anything of SN2, there are certain keywords, like first important keyword for SN2 is what? Backside attack. Second important part, in case of SN2, child, in case of SN2, the first important keyword is backside attack. Point number 1. Point number 2, since it's a bimolecular reaction. Now if it is a bimolecular reaction, let's have one more discussion. The rate is directly proportional to substrate, which is alkyl halide, and even a nucleophile also plays a very important role. In SN1, nucleophile is not involved in rate determining step, but in SN2 your nucleophile is involved. So, to carry out your SN2 reaction better, your nucleophile has to be strong. So, this is your correct point. Now, why are the other things? Let us see. Now, weak concentration of a nucleophile. Suppose if your nucleophile is weak in nature, concentration wise or strength wise, even your rate also will decrease. So, here it cannot be the answer. Okay. Second point, since you know that over here tertiary alkyl halide cannot be there, because when you have got a tertiary alkyl halide, what is tertiary alkyl halide, child? I think so, it's a halide having 3 carbon atoms over here. And if you see the example, when I put methyl, can a nucleophile can attack from backside? No, because this 3 methyl group will start repelling it. Because of steric hindrance, your nucleophile cannot attack tertiary, and that is why practically tertiary alkyl halide do not undergo SN2. So, even this is not the answer. Is it clear? That is the meaning of backside attack what has been given to you. And last, polar protic solvent. Now, polar protic solvent is not required for SN2, it is for SN1 where carbocation is formed. So, SN2 के लिए बच्चा क्या terms था, if you remember? Yes, SN2 reaction is favored by polar aprotic solvent. Hence, even this answer is also incorrect. I hope this is clear. So, your correct answer has to be A. Is it clear? Let us move to the next question. Okay, now this is one of the very common reaction, child, nucleophilic substitution reaction, and I think so if you are aware, yes, alkyl halide, when it has been treated with KCN and AgCN, what is the product obtained? Same way, there is another set of reaction, child, where your alkyl halide is treated with KNO2 and AgNO2. I think so in both these cases, child, if you see, they are ambident nucleophile. So, attachment can take place from either atom. Let us see in the first case. In case of KCN, child, your product obtained would be cyanide only. But in case of silver cyanide, the product obtained would be isocyanide, and I think so we have discussed in this class, this is due to nothing but what your KCN is more of ionic character and silver cyanide is more of covalent character. Now, same thing you have got over here also. In case of KNO2, you will get RONO as the product form, and in case of silver, if going with halogen, the product obtained would be nitro. So, the question is again same, this will be more of ionic character, this will be more of covalent character, and that is why you get 2 variable products over here. Now, let us see and check. Whenever it is a KNO2 given, you get O no as a product form, that is nitrite, which is correct. So, this is correct one. But wait, we have to find out correct? No, we have to find out does not take place properly. That means this is answer is correct, but this is not our question. Okay, child. So, we will cross this. Next, silver cyanide is given. Silver cyanide always gives cyanide, no, isocyanide, and yes, it is given isocyanide. So, even this answer is also correct, but this cannot be our option key answer, because we have to find out does not. Now, silver nitrite is this one, it gives you nitro, yes, it is given correct, but this cannot be the answer because we have to find the incorrect one. And last, which is left out, in case of KCN, we can never get isocyanide. We can get isocyanide, but in minor amount, but not as a major product, and that is why this answer is our correct answer. I hope this is clear, child. Fine. Yes, let us proceed to the next question. Now, here, child, what they have given. Among the following, which one has got weakest carbon halogen bond? Now, before we start anything, child, let us write the structure of all the compounds. If possible, some of the kids may not know or recollect. It's a benzene attached to bromide. First example. The second example is bromobenzene, that means this is this type of example. Now, next one, vinyl. So, vinyl is something of this type. Okay, good. Now, next one, it's nothing but your D, benzyl chloride. Now, kids, before we start anything, one thing is missing, child. I have written the first example which is incorrect. Benzyl bromide is something, correct? So, this was the reason why I had written like that. So, I think so you must have got recollected. Fine. Now, correct. Now, it is correct, bacha. Okay, what is the first point of discussion? Which is the weakest bond? Now, first of all, go to example number B. Do you have got lone pair over here? Yes. So, will it get involved in resonance? And due to resonance, what will happen? It will get a double bond character. Double bond character. And that is why what will happen? That is why bond order will increase. So, even a bond strength also will increase, and once the bond strength increases, bond breaking is difficult, not easy. Same story you have got over here also. If you check, again the same story. That means these cannot be the answer. Is it clear, child? Now, only the answer left out is what? Out of these two. Now, here there is no as such resonance. As this part goes out, you will get carbocation form. Yes, and as it goes out, you get your carbocation form, and both the carbocations are stable. That means both these compounds can undergo breaking easily, but again in that also your one more concept comes, which is leaving group ability. Leaving group ability. Now, in case of leaving group ability, child, I have told you already is, what is that? Iodides are more reactive than bromides. Bromides are more reactive than chlorides, and chlorides are more reactive than fluorides. So, out of these two, the most important, like that both of them are reactive, but the best one would be this one to undergo breaking fast, and this will be little bit second, but we have to find out only one option correct. So, more appropriate answer is option A. I hope this is clear, bacha. Is it done? Let us proceed to the next question. Now, child, the question given to you is assertion reasoning. What is the first one? It is necessary to avoid traces of moisture from Grignard. Yes. And second statement, Grignard reagent reacts with water and forms hydrocarbon. I think so both the statements are correct, child. Let us justify this if you want. Now, see, whenever if you have got a Grignard reagent, how we write a Grignard reagent? RMgX. Suppose by chance, if there are some traces of water, suppose available, what will happen? You know that your Grignard reagent has got delta minus R, which is a nucleophilic center. Yes, and do water contains and acidic protons. That's why we call water, alcohol, etc. as protic polar solvents. Now, what happens? Your R as a conjugate base will combine with this H, and you will get nothing but the answer as hydrocarbons, alkanes, and the byproduct will be obtained, which is of right now no use, but still I will write. You have got over here X and OH. Main important is what? Whenever if you are using a Grignard, we always use dry ether as a solvent medium, not a water. Reason, it will start reacting with water to give you hydrocarbon. I think so both these statements what you can see are correct. So, your correct answer has to be both A and R are correct, and R is the correct explanation of A. I think so correct answer has to be A. I hope this is clear, child. Let us take the next question. Okay. Now, this question is again very simple one based on reduction. Now, child, tell me one thing. Sodium borohydride only reduces your ketone group, yes, and not an ester. That means your ester group will remain unaffected. Is it clear, child? So, this side you have got C. So, C is what we have to find out. Now, see over here your ester remains as it is and only this has changed to secondary alcohol. So, ketone on reduction gives secondary alcohol, ester is unaffected. That means your C has to be second. So, C has to be second. Now, see first of all you should understand one thing, both of them will have different product because lithium aldehyde will even break ester linkage also. So, this cannot be the answer, this cannot be the answer. Now, what is the next situation? Now, we told that C is second. So, C is second is in this answer. So, your correct answer is this, and if you still want explanation I can give you. Do you know lithium aldehyde will break this bond? You will have H over here and H over here. So, this aldehyde also will convert to alcohol, this will also become alcohol, this will also become alcohol. That is why you have got 3 alcohols over here. I hope this is clear, child. So, your correct answer in this case is option A. I hope this is clear. Let us move ahead. Now, this question is again a simple one, esterification. Do you remember one logic in esterification, child? What was that? See over here. Whenever a carboxylic acid is allowed to treat with an alcohol, correct? What happens? What happens? From where your OH part is lost? Acid में से OH part is lost and H part is lost from alcohol. This was told to you. So, you get an answer as ester. I think so it is clear, and your water would be a byproduct. My question to you is, suppose if oxygen 18 is given as a labeled oxygen, you know that water is going to be lost. Where your labeled oxygen will be present? I think so it will be present in ester only, and I think so this is only that question if you see. So, your OH part is lost from an acid and H part is lost from this to form water molecule, correct. So, the ester obtained would have 18. Now, ester would have 18 is only one option what you can see most probable. I think so this is the answer key. So, your correct answer is B. I hope this is clear, child. Fine. Let us proceed with the next question. Okay, this is one of the very common reaction, child. Let us write and check. Let us write and check. I will do one thing, just give me a time. Okay, let us do this reaction once again. Now, here I have got something called as CH3, then I have got CH, CH3 and OH. I think so this compound is known as propane to all. Now, the first step what they have mentioned is oxidation, and alcohol, secondary alcohol on oxidation, yes, gives you ketone, and I think so the ketone what we have got is of this type, and that is nothing but propane to one. Yeah, we can write propanone or acetone. So, no need to indicate the position in this case. So, first step you have got this as a byproduct. Now, the second step is what? It is nothing but a treatment with methyl magnesium bromide followed by H plus ion hydrolysis, and that is step number 2. Child, if you remember aldehyde ketones when reacts with Grignard, it is going to form you alcohol. So, what is the concept behind that? This is the delta negative part, this is delta positive part. Here in case of carbonyl group, this is delta minus, this is delta plus. So, can I call it a nucleophilic addition what you have got? Yes, and the product obtained will be what? CH3, CH3. Here you have got O, correct? Your methyl part has been added over here, and you have got over here that magnesium halide which will later on get hydrolyzed. So, you will get nothing but tertiary alcohol, and the name of this compound I think so it is 2-methyl propane to all. Now, let us read the question properly, child. Now, what they have told that about this reaction, this is compound Z, okay? Let us see the question. Choose the correct option from the following, and they have given some statement. The product Z is nothing but 2-methyl propane to all. Yes, I think so it is a correct one. So, this is the correct step. Product Y is acetone. Yes, this compound propanone having a commercial name or a common name as acetone, which is correct. Now, step 2 is nothing but nucleophilic addition. Yes, it is a nucleophile which is added followed by hydrolysis. This is only nothing but what you have got in hydrolysis, child. So, even this step is also correct. So, you have got A, B, C all correct. Now, let us see the D one. Step 1 on oxidation of alcohol into corresponding acid. I think so this is not the correct one, because in this case we get ketone. So, this cannot be the answer. That means your correct answer has to be your A, B and C. I hope this is clear, child. Yeah. Let us take the next question, bacha. Okay, this is one of the very common reaction, child, if you remember. Now, child, this is a phenol, and phenol, when it has been treated with NaOH, it forms salt, and then you have got carbon dioxide. Child, if you remember, this is coal-base reaction, and in coal-base reaction, what is the product obtained, child? The product obtained is salicylic acid. And what is salicylic acid, child? Out of this C, this cannot be a salicylic acid. So, we can cut this option here only. So, no need to write. This is also not a salicylic acid. So, even cut the answer. Now, wait. If you see over here, they have given acidic condition. Now, when acidic condition is there, if both of them are salicylic acid, by the way, correct? But since acidic condition is there, you can't have that salt formation. You can't. That means even this answer is not correct. And the final answer is this, which is nothing but formation of an aspirin, and this is aspirin molecule, child. I hope this is clear. So, how I have eliminated, I think so you have understood. Is it clear, child? Let us take the next question, bacha, what we have on the screen. Yeah. Now, child, before we start anything, KMNO4 is an strong oxidizing agent. Now, if it is a strong oxidizing agent, child, what will happen? First of all, is this a primary alcohol? Is it a secondary alcohol? Secondary alcohol. And is it a tertiary alcohol? Point number 1, tertiary alcohol will not undergo any oxidation, because primary and secondary alcohol undergoes oxidation easily. Point number 1. Acha. Second thing, your secondary alcohol will get oxidized to give you ketone. Your primary alcohol will get oxidized to give you aldehyde, but since oxidizing agent is strong, this aldehyde will also get converted to an carboxylic acid. That means you should have got in your answer one acid group, one ketone group and one tertiary alcohol as it is. So, your correct answer key has to be C. I hope this is clear, bacha, to you. Yes, confirm, koi doubt, any doubt in this case? So, your correct answer is C. Let us take the next question, bacha, what we have. Okay, this is one of the very simple question, child, again. A compound A with the molecular formula given as this C8H2O is found to react with NaOI, produces Y by reacting, produced by reacting Y with NaOH and yields yellow PPT with a characteristic smell. I think so, bacha, before we start, it's something related to iodoform test, and in iodoform test, always what we have 4 types of compounds who can give this test positive. First, can I have a compound which contains a methyl ketone group, the first compound who can show iodoform test positive. Second, secondary alcohols are those compounds which can again show iodoform test positive. Exceptional aldehyde, acetaldehyde and exceptional alcohol, ethyl alcohol. All these 4 compounds, when you treat it with NaOH plus I2, they all will give this test positive, because NaOH plus I2 only combines to form NaOI, and I think so as per the correct option. You should know that I2 is given everywhere. So, that is the hint given to us. Now, it is nothing but this group which you can see can show iodoform test positive. Rest of the groups are not exactly matching. So, your correct answer has to be C. I hope this is clear, child. Fine. Let us proceed with the next question what we have. So, let us begin with the kids this question what you have got on the screen. Now, in this reaction what they have given, they have given one benzaldehyde, which I think so you can see very clearly, and another one is formaldehyde, and it is treated with a concentrate KOH. That means it's nothing but a reaction where your aldehyde and ketones are there with base. Now here there are only two possibilities, one is Cannizzaro reaction and other one is aldol. But the question is, for aldol you require alpha H containing aldehydes, but here I think so both the examples what you have got are of non-alpha H containing compound. That means this reaction has to be Cannizzaro. Now in Cannizzaro reaction, child, basically what is a reaction? When two molecules of an aldehyde, when treated with a concentrated base, one of the molecule gets converted to a primary alcohol and another molecule gets converted to a carboxylic acid salt. So here you will have a mixture of two products, one is alcohol and one is acid. Which alcohol? Primary. So let us now see first of all, over here in this question, child, they have given a question having two different aldehyde. That means it is an example of cross Cannizzaro. Now in cross Cannizzaro, child, first of all, if you see here you have got one acid, but here you have got an aldehyde. This cannot be the case as the answer key. Now let us see the concept. Now child, before we start anything, you just tell me one thing, both of them are aldehydes, correct? Now do we know that aldehydes like to undergo oxidation? Yes, to give you carboxylic acid. So both the compounds are easily prone to show acids. Means any substance who want to show oxidation, can I call it a reducing agent? Now out of these two, who is a good reducing agent? We know that, and that's the reason over here your formaldehyde is a more stronger reducing agent, so it will reduce the other partner and himself will get oxidized. So formaldehyde will always gets oxidized to an acid, correct, and the second component will get reduced to a primary alcohol. So your correct answer key has to be option C, where your aldehyde becomes primary alcohol and your formic acid gets converted to a carboxylic acid. I think so this is clear. So your correct option is C in this example. Is it clear, child? Yes. Let's proceed with the next question, child, what we have on the screen. Now child, the question given to you is again a very simple one. Let's write it properly and do that discussion. Now this question is again based on ozonolysis. Which compound would give 5-keto 2-methyl hexanal upon ozonolysis? Now before we start that, just do one thing. If I break this bond during ozonolysis, both the sides I will get O, and if you see these are non-terminal, that means this is a ketone and this is also a ketone after breaking. Over here if you check, child, after doing ozonolysis, here you will have O, here you will have O. So one of the compound is a terminal one, so it is an aldehyde, other one is compound is a ketone. Now again in this, child, if you keep on breaking it, this side O and this side O, ozonolysis. So here it is again a terminal, so this has to be aldehyde and this has to be ketone as per the, after breaking it would give you obviously. Now here if you carry out ozonolysis on this, child, here you will have O, here you have got ketone. Why? Sorry, both the sides you will have got ozonolysis done. Yes, this side I will get aldehyde, this side I will get ketone. Now my question to you is, first of all let us use the elimination technique. In my compound I have got one keto group and one aldehyde group. That means your all three options B, C and D are possible, but your option A is not possible, that is clear. Now next important thing, what is the position of a methyl group? It is a second, means it should be immediate next position to an aldehyde. Now aldehyde carbon after breaking will be this one, which is the first position, this will be the second. So it is a 2-methyl what you will get a compound. Over here if you check, it is the first carbon after breaking takes place. So this will be first carbon, this will be second and this will be third. So third methyl, and here in this case this will be your first carbon, this will be second, this will be third, this will be fourth. So as per the question, you do not try to write everything, child, use a logic. So here it is nothing but 2-methyl. So your correct answer has to be B as the correct option. I hope this is clear, child. Let us take the next question. Now here the question given to you is what? A very simple one. A benzene is given to you as the compound. Treat this with methyl chloride in presence of AlCl3. I think so this is Friedel-Crafts reaction, I think so, Friedel-Crafts alkylation, where the option or the product would be toluene, what you have got. Is it done? Now this compound toluene, on further carrying out nitration, now after nitration child, what will happen? Your second group, which is nitronium ion, I think so, because of it will be there of this agent, I think so this is a donating group, and donating group always gives ortho and para product. Since over here nothing is mentioned as per the question, we can see only the major product you will see. So, electrophile will attack to a para position much better. So, over here the product obtained would be, you would have over here a methyl group, and to it a para position you will have got nitro. So, you have got para nitro toluene, and as per the situation, your compound A is a toluene, your compound B is nothing but para nitro toluene, and the last one they have given as something called as KMnO4. I think so KMnO4 is an oxidizing agent, and since it is an oxidizing agent, it will oxidize your methyl group to a carboxylic acid. So, over here your answer has to be a benzoic acid formed, and to it a para position I have got nitro. So, this is my compound C as per the reaction given to you. So, out of 4 options, I think so the most appropriate option in this case is D. I hope this is clear, child. Let us take the next question. Now, this is one of the very common reaction, child, of your syllabus. Let us see what we have. We have got over here a 3 carbon atom acid called as propionic acid. Now, treat this with Br2 and red phosphorus. Child, if you recollect this reaction is known as HVZ reaction, which is known for halogenation at alpha position. So, you have got this as alpha carbon, to that you have got one H and one Br will get lost. So, you will have HBr as a byproduct, and your product obtained would be CH3, CH and acid, and on alpha position you will have got Br. So, this is nothing but alpha bromo propionic acid. Now, this is my compound X. Let us take the next step. Treat this with ammonia. Now, if you remember, child, when you treat this with ammonia, do you remember one reaction where halides gets replaced by an amines, which is called as Hofmann ammonolysis, and in this reaction nothing additional condition is given. So, can we get over here your primary amine as a major product? So, here you have got Br, here your H has got lost, you will get nothing but the answer as CH3, CH, COOH and NH2. So, can I tell that the compound what I have got is alpha amino carboxylic acid? That means this is alpha amino acid, and this compound is well known by a name called as alanine unit. I think so you all are aware about this, child. I hope the correct answer for this MCQ is option B. Is it clear, child? Let us proceed with the next question, child. Now, over here the question is again a very simple one, child. You can see over here they have given an acid which has been treated with SOCl2. So, what will happen, child? I have got CH3, CH2, CH2 and C double bond O with OH, correct? This is nothing but your starting material, correct? Now, when you treat this with SOCl2, now what SOCl2 does, child, if you remember, it replaces your OH group to Cl. Yes, so what is the answer, child? It's a CH3, CH2, CH2 and C double bond O with Cl. I think so this is nothing but a product A, and it is known as acid chloride. Now, the second condition is a most well known condition, child, you already know, it's H2 gas. Along with that you have got palladium with barium sulfate. I think so this condition is called as Linder's catalyst, and which is used for reduction. So, here you will have got, you know that acid chloride, you have got Cl is a leaving group, it will come out with H, and over here also you will have H. And if you know, Rosenman reduction is used to prepare only and only aldehydes. So, your product obtained would be aldehyde. So, your correct answer for your MCQ, where your A and B what need to be find is this one, where you can see aldehyde is there. That means your correct answer is B. I hope this is clear, child. Let's take the next question. Now, this is one of the very good question, child. Which one of the following is not formed when acetone reacts with 2-pentanone in presence of dilute NaOH followed by heating? Now, see, if you remember, it's nothing but aldehyde. Yes, two aldehydes are treated with NaOH, of course, which contains alpha H. That means it's an aldol reaction, correct? Now, point number 2, suppose which two aldehydes they have told? One is acetone, so I'll write acetone over here. Yes. Second, they have given us pentane 3-one, so pentane 3-one. I have written in some different way, child. It's pentane 3-one. Now, my question to you is, do both of them they contain the alpha H? Yes. So, if both contains alpha H, yes, your number of products will be more. Your number of products will be more. That means, let's say there will be 4 products which can be obtained. Is it clear? But one more thing is very clear. Let's see first of all. Now, what is the logic to find out? See over here. Now, I have given you one hint in the lecture. Just check it's an aldol product or no. So, break this bond, put O on this side and put on H on this side. Do you get this unit is an acetone unit? And I think so this unit is pentane 2-one unit. Yes, this one, this unit. Let's take this unit now. If I break this bond, O is on this side, put O on this side. So, this unit becomes acetone unit, and this unit, if you check, becomes your pentane 2-one unit. Now, break this bond also and check. Yes, I think so we have got over here O and we have got H over here. I think so. Is it clear? Is it clear? So, here this unit is acetone, this unit is acetone. So, both of them are nothing but acetone, and obviously even a self coupling is also product, one of the case when you do. And last example is nothing but where you have got O on this side, you have got O on this side and H2 on this side. So, here you have got pentane 2-one, and here also I have got option is pentane 2-one. Now, my question to you is, child, like that if you see all 4 products on paper are possible, but you know that aldol is nothing but an example of a nucleophilic addition, correct? Now, you tell me, do aldehydes and ketones, which one likes to undergo aldol condensation easily or nucleophilic addition easily? I think so it's an aldehyde. So, ketones are the compound which will be comparatively less reactive for an aldol. Yes. So, out of which all the example if you see over here, you have got this example which is more prominent, where ketone only reacts with ketone, and that is also bulky ketone. Because see, in the second last example, acetone still it is possible, but in case of pentanone only will attack pentanone is somewhere not that great possible because of addition, because lot of steric hindrance will come into picture, and that is why you will see that this is only the product which cannot be formed. That is only I think so what they have asked. So, here all 3 will be formed. So, your correct answer in this case has to be D. This is only one answer which I think so it would be a little bit challenging, but yes, let us see the next question then what we have. I hope this is clear, child. Next question, what we have on the screen is, okay, now I think so, what do you know? First of all, do you remember, bacha, what is this LAH? LAH is nothing but lithium aluminum hydride. And what is the work of a lithium aluminum hydride? It will convert your carbonyl group into methylene group. So, will I get nothing but the compound called as ethylamine? I hope this is clear. Now, do you remember this condition, bacha? This is only one condition which some of you may not recollect. It is actually nothing but Br2 plus KOH or NaOH. Do you remember this is called as Hoffman bromamide degradation. Hoffman bromamide degradation. Now, what do you mean by this process, child? The shortcut of this reaction is just remove one CO group and you will get nothing but amide getting converted to an amines with one carbon atom less. I think so in both the cases you have got the answer. Now, what is the relationship between A and B? I think so they are not functional isomers, they are not identicals because they are two different compounds clearly. Acha, they are not chain isomer also because for our isomers to take place, they should have same number of carbon, same number of hydrogen, same number of nitrogen. Here they are the correct option as they are homologous member. Now, what is homolog? I think so they are series of a compound where they have got a same functional group, but each member differs from the next member by one CH2 group. So, can't you see that over here this is the lower member and this is the next higher member. So, do they differ by one CH2? Yes, and that is why the correct answer in this case is B, which is homologous. Is the term clear, child? Yeah, hope so it is clear. Let us go for the next question. Now, child, over here they have given one set of reaction again. I think so we have got over here is carboxylic acid, which I think so you can see clearly over here as acid, correct? Now, when this has been treated with ammonia, now before we start anything, do you know that acid when reacts with a base, it forms a salt. So, can I tell first of all acid will have a loss and base will have a proton acceptor. So, the answer would be CH3, C double bond O, O minus, because acid when it loses H, it forms a conjugate base, and base when it accepts a proton, it will form conjugate acid. So, will I get a salt form? Now, this is nothing but my compound A. Now, second step, when you heat this, obviously there will be a loss of a water molecule from it. There will be loss of water molecule from it. Now, the product obtained in this case would be an amide which is formed. Is it clear? That becomes my compound B. Now, what is the next step you have got, child? I think so it's a P2O5. Now, I don't know how many of you remember, but I think so P2O5 is a dehydrating agent. Can it remove your water molecule from this? Now, when a water molecule is lost, will I get nothing but a cyanide obtained as a compound? So, that becomes your answer C. Now, last part. Child, cyanide on treatment with sodium and ethyl alcohol. Do you remember, bacha, one of the reaction which is reduction, and this reaction is one more well-known reaction called as Mendeus reduction. Do you recollect that, child? Where your cyanide gets converted to primary amine. That means the final answer, what are you going to get as a D would be an amine. So, your correct answer for this MCQ is B. I hope this is clear, child. Let us take the next question. Now, child, over here they have given what? A compound X reacts with benzene sulfonyl chloride. I think so this is only known as Hinsberg reagent to give you compound Y, which is insoluble in alkali. The compound X is. Now, child, if you remember, this answer is like this. Suppose if I have got amines over here, which amine? Let us see over here. Suppose if you have got a primary amine or you have got a secondary amine or you have a third or tertiary amine. Now, let us see how all three will do the process. Now, when a primary amine is treated with benzene, sulfonyl chloride, yes, what will happen? Same thing what I will do is, I will copy this again and put it over here. Same thing I will copy and put it over here. Point number 1, I think so tertiary amine will not react only with benzene sulfonyl chloride, because it does not contain that active H which reacts with Cl of this compound. Is it clear? In as first and second, primary and secondary, both will react to give you some product, a Hinsberg product of primary amine, Hinsberg product of secondary amine. Now, the second step is, when this is allowed to treat with an alkali, what happens? Being a primary amine Hinsberg product, it is going to form a salt, and salt is soluble in water. Whereas in the second case, when you treat this with alkali or alkaline medium, yes, I think so they have given alkali, so we will also take alkali only. So, here if you see, it is an alkali, either KOH or NaOH. Here no salt formation, and no salt formation means it will be insoluble in water. That means, if you see now the question properly, a compound X, any one of them it can be, reacts with benzene sulfonyl chloride to give you some product. See over here they have given Y, and which is insoluble in alkali, means it is insoluble in that particular water, that is nothing but what you will have got called as dilute alkali. That means your starting material has to be a secondary amine. Now, secondary amine, I think so it is this one. So, your correct answer has to be A. I hope this is clear to you, child. Let us proceed with the next question. Okay. Now, the next question what we have is, beta, I have got over here aniline unit, where you have got NH2, correct, and it has been treated with nitrous acid. When you treat it with nitrous acid, the first thing what you will get is nothing but a diazonium salt form. Is it clear? Temperature is mentioned as 280. Now, the product obtained would be this, benzene N2 plus and Cl minus. Now, second step is boil it with water. Now, when you boil it with water, what will happen? Your HCl will get lost, N2 is also lost. So, you will get nothing but your compound called as phenol, and I think so your option X product is nothing but phenol. Now, this phenol went on treatment with NaOH. Now, we know that NaOH is a base, phenol is an acid. So, it will have a loss of water molecule, and you will get nothing but salt form, and the name of the salt would be sodium phenoxide. Is the term clear? Now, last step, child, what you can see, this is nothing but a compound Y. Now, last, treat this with methyl iodide. I think so, child, you should know one thing. I think so, whenever if you have got a salt of an alcohol with alkyl halide, can I call it a Williamson's ether synthesis? Yes, because here it is a delta minus, here it is delta plus, here it is a positive part, here it is a negative part. Do alkyl halide likes to undergo nucleophilic substitution? Yes, so here your NaI will get lost, and will I get nothing but a product formed is sodium, you will get a product as benzene attached to O and will attach to CH3. Can I call this molecule is known as anisole or methoxybenzene, and as per the option key, your correct answer has to be C. I hope this is clear, child. Yeah, let us take the next question. What you have on screen now, the end product of the following reaction is, I think so this is one of the very common reaction, child, where what will happen? I think so this is a benzene unit having over here N2 plus and Cl minus, correct? Treat this with cuprous cyanide with KCl. What will happen? Your N2 part is lost, your Cl will go with this K, so you have got N2 gas byproduct. You have got the next one, which is KCl as a byproduct. What is left out now with child? I have got over here a benzene ring containing a cyanide unit. Now, this cyanide on hydrolysis, now we I think so know that cyanide always on hydrolysis gives what? I think so it gives you an acid. So, the product obtained in this case will be benzoic acid. So, your benzoic acid is nothing but a product Y, and your this product is the product X. Now, what is the last step? Last step is a treatment with soda lime. I think so we all know soda lime is used for decarboxylation. So, what will happen? Your carbon dioxide would get removed from it, decarboxylation, and you will get nothing but the answer as benzene. So, this reaction can be used to prepare an aromatic compound called as benzene, which is generally called as arenes. So, I hope the correct answer in this case is very clear. It is nothing but an arenes. The final answer, which is nothing but your product Z. Is it clear, child? Is there any doubt in this particular case? I hope this is clear. Let's proceed with the next question, child. What we have now, child, one thing is very clear. What you have got over here? I think so you have got over here, it's nothing but a secondary amine, okay, and over here I have got a reducing agent. So, which compounds on reduction gives you secondary amine? I think so it's nothing but isocyanide who gives a secondary amine. Now, isocyanide is obtained and here you have got KOH plus this. I think so this is one of the very common reactions shown by primary amine, carbolamine test. And I think so out of this example, I think so you have got one amine which is D. Let's rewrite and check. If I have got ethylamine, yes, and treat this with chloroform plus KOH, will I get nothing but ethyl isocyanide, yeah, ethyl carbolamine as a product? This would be a product B. Now, this compound on reduction with lithium aluminium hydride, what will happen? You will have your compound where reduction takes place. So, your cyanide group, isocyanide group will get converted to secondary amine. And I think so this is nothing but a very clear cut answer where your compound A has to be an primary amine. So, your correct answer in this case is nothing but option D. I hope this is clear, child. Let's take the next question. Okay, now one thing very clear, child. A polysaccharide is composed only of beta D glucose unit. Now, I think so, child, you are aware about suppose of polysaccharide, correct? Now, in polysaccharide is nothing but a polymer of monosaccharides, correct? Now, they have mentioned over here beta glucose, correct? Now, see, as per the situation, if you know starch, yes, starch is only made up of two things, yes, one is amylose and suppose other one is amylopectin. I think so this is clear, and starch is actually nothing but a polymer of alpha glucose. Is it clear? Now, second polymer what you have polysaccharide is cellulose, and I think so we know it's very clearly cellulose is nothing but a polymer of beta glucose. Is it clear? So, what they have mentioned is I think so correct. A polysaccharide is composed only of beta D glucose unit which are joined by glycosidic linkage between C1 and C4 with the next glucose unit. Name the polysaccharide. The most common polysaccharide in that case is a cellulose. So, the correct answer for this is option B, and I think so it's a factual data, child, you have studied also. Let us see the next question, Bacha. Now, this is one of the very good question, child, what we have. In a DNA, if 10% of guanine is present, how much thiamine is present? Now, some of the kids may be thinking, sir, how guanine is related to thiamine? I will just tell you one thing. See, one thing is very clear in a DNA chain. What is that? Something called as base pairing. Now, suppose if you have got over here an adenine, obviously the complementary base would be nothing but a thiamine. Same way, suppose if you have got over here a guanine, the complementary base would be cytosine. That means your base pairing is what? Base pairing is that where adenine is combined or joined with thymine by a double bond, which is hydrogen bond. Guanine is attached to a cytosine by a triple bond, which is a hydrogen bond. That means from this, can we make one thing? The amount of adenine is always equal to amount of thymine. Same way, amount of guanine is always equal to amount of cytosine. Is it first of all clear? Now, suppose what they tell, what they are telling as per the question, if I have got guanine 10% of the DNA chain, it implies that even a cytosine is also 10% of the chain. That is, guanine plus cytosine will be approximately 20% of the nucleic chain of a DNA chain. So, as per the concept of percentage in DNA, your adenine and thymine percentage together has to be somewhere 80. Now, you tell me your adenine is equal to thymine. So, if adenine is 40%, then only your thymine also would be a 40% as per the question what is mentioned, and that is why the correct answer in this case has to be a 40%. So, this is not something very difficult, it is just the one you have to just logically think. I hope this is clear. Let us take the last question, bacha. Now, here there are statements given to you, child, yeah, and one thing is mistake in this, I will just tell you. What is that? This is extra statement, child, which has come, which is extra statement. Now, the first question what you have got is statement 1, glucose on acetylation gives pentaacetate, and I think so it is a correct statement. And statement 2, it contains 5 hydroxy group. I think so it is correct, because glucose has got 5 hydroxy group and which can be analyzed by using acetylation. That means both the statements are correct. That means your statement A is correct for this MCQ. I hope this is clear, child. Yeah. So, here there is one silly mistake. Here by mistake this statement was also printed. So, I am just removing out. I hope this is clear. Yeah. So, in today's paper I hope you must have done well. Thank you very much, child. Take care.